This tool would have been calibrated to air pressure, would have an air hose and stuff on it.
And 5 years ago, this would have been the tool Bill Knight would have used to tighten bolts on the locomotive engines he repairs. The hard work would have strained his back or possibly caused him injury. On top of that, there was the risk of human error.
It kind of goes backwards to allow you to get onto the bolt.
Today, he simply guides the tool to the bolt on the computer screen and squeezes the trigger. Should he go to the wrong bolt, the machine won't respond.
The screen does not turn blue, and my spindle will not turn.
Our facility remanufactures diesel engines for locomotives.
And it's just one of the features of GE's so-called Brilliant plant in Grove City, Pennsylvania. Jeff Smith is plant manager.
Brilliant Factory is really 4 pillars. There's the digital thread that's connecting the data pieces, collecting the data, and running advanced analytics.
To create the digital thread, each piece of the engine is marked with a barcode.
When they scan it, the operator generates the work order.
There's lean manufacturing principles, which is all about simplification, visual management, and reducing waste from your process. There's advanced manufacturing where you utilize tooling and other types of things to mistake-proof processes and also to build your digital data. And the last piece is additive manufacturing.
5 years ago, GE converted this 240,000 square foot plant into one of 6 Brilliant plants it operates across the globe. The plant employs 330 hourly workers and another 70 managers.
We collect the data. Now we collect it not only automatically, but we collect very accurate data. So the data accuracy is auto-collected. So we begin to build the digital thread so we can begin to analyze data, as well as create advanced analytics so we can predict better incoming material, core condition, and customize work scopes accordingly.
We used to do it just on paper.
Keith Spahn spends his time inspecting metal plates to see if they're fit for service. At another plant, the process would be time-consuming and involve lots of calculation.
You have a scanner, you have your barcode.
Here, Spahn just needs to read the machine.
If it's good, it's in green. If it isn't good, it turns to red.
Smith says one of the goals is to create a totally transparent environment to encourage communication. Throughout the plant, you'll find flat-screen TVs giving real-time updates on production.
The concept of the digital thread and building that digital twin is all about capturing the genealogy of the part, not only of when it's just remanufactured, but also through its service life throughout the field, how it runs, operating conditions. Then you marry that up with the data we have from when we remanufacture it, run it through the analytics to understand and better predict outcomes, whether it's in reliability, maximizing the life cycle of a component, quality, or just even advanced ordering material to supplement when things may come out of range or coming up with new repairs. Everything has to be washed twice. You can look and say, hey, you know, my pyrene's too light.
The idea, Smith says, is to make everything as simple and efficient as possible. The room where the engines are assembled is positively charged to keep out dirt, and every tool a worker will need has a clearly labeled space at their station.
We've been able to utilize the Brilliant Factory concepts to increase utilization of machines by up to 20%.
You can read the story behind this video in the mid-May issue of the Business Journal, out now.